Hi everyone, this is a policy manager presentation developed by Fernando López Aguilar from Telefónica and Guillermo Jiménez Prieto from Idea Software Institute. This component is part of the cloud chapter of the FIWARE project. First of all, the technologies that the policy manager uses are Python. All code is written in Python and it works under the Django framework. The core of the RAL engine part is Clips, and the framework to connect Python with Clips is PyClips. It also uses Redis as cache database and RabbitMQ for message forwarding as facts. Finally, MySQL as database to store rules, servers, and subscriptions. The policy manager mission is to provide policies to get a relative autoscaling of virtual machines. It could be used to get notification about different facts that are taking place in the cloud and actions to be launched. Those facts and actions are executed when certain conditions are taking place. They are launched informing users, and it could be launched to a service or an email server too. However, there are a lot of examples for applications. You can design policies for connecting data from virtual machines, CPU, memory, disk, and network usage. And using this data to define your own conditions and actions. It should be performed as load balance, moving virtual machines from a node to another node with lower usage, increasing resources of a virtual machine, or even deploying more virtual machines of the same instance or service. Another one could be availability policies. If a virtual machine is dead or stops working, we can restart it and deploy virtual machines on different nodes, whatever. The policy manager provides a REST API. We design our component as a REST service to be deployed on a server application. In this way, a user could design his own rules and publish into the code, increasing the potential to the infinite. Policy Manager is open source, and it's possible to modify the code or add new features without any problem. Rules are written in human language, JSON. We consider to use a formal language for the rules, but then we prefer to make easier written rules for users. We parse JSON to Clips language, verifying and detecting errors in the rules. That simplifies the life to users. Users can also implement their own actions from a notification. Finally, Policy Manager has been thought as a notification facility, but users can generate their own behaviors from these notifications. This is the basic scheme of the Policy Manager. One client interacts with the API, and API interacts with the rule engine, which recovers data from database and stores new data on it, recovering rules or inserting new rules. Rules engine also interacts with action components that launches actions to OpenStack service. Going deeper into the functionality, this is a real working flow in the Policy Manager. Flow starts with a post request, which contains conditions, actions, and the server ID of the server affected by the rule. The API engine takes care of storing those conditions and actions into the database. Once the rule is created, a second post request should be performed in order to subscribe the server to a defined rule. The user sends the request, policy manager will send a subscribe request to the contest broker, and contest broker will get data from the server subscribe. At this point, contest broker starts sending put requests with data containing CPU, memory, hard disk, and network usage to our component FIWARE facts. This component generates facts, storing this data into a Redis server acting as cache. It generates an average with the amount of facts defined in the tenant window side. This component throws a message with the average to a queue of RabbitMQ. On the other side, FIWARE Cloto will get average from Rabbit with its environment generated by the environment manager, one per existing tenant. Each tenant is evaluated by its own environment, taking only facts owned by itself. Environment takes conditions and action too, evaluates rules with the averages reside, and if one condition is taking place, Clips returns the actions. Environments executes the actions against an external service, and this service should be in charge of performing some actions in OpenStack, Nova, Cinder, or any other service. Looking to the rules definition, this is an example of a policy manager rule. It defines the action that will be launched when the conditions are taking place, the name which defines the rule. This is a simple information for the user. It should help him to identify the rule with a descriptive name. And finally, the conditions, which are based on CPU, memory, hard disk, and network, and the operands for each parameter. This is the API information about resources that user can invoke, servers, rules, and subscriptions. If we get servers, we will get all servers registered in the tenant. If we get a server, we get all created rules and subscriptions for that server. Rule ID returns information about that specific rule, and subscription ID should return the URL of the subscription and contest broker subscription ID. All these operations need authentication. Each request launched against Policy Manager requires a header. This header must contain a valid token obtained from OpenStack instance. Header have these appearance: exhaust token as name and the value. Remember that this is an HTTP header. Okay. Attending to the operations, there are different API operations. General operations, get info API returns information about the starting date of server, the version of policy manager that is deployed, documentation information, etc. Update window side modifies the number of facts to be managed in the fact average for each tenant. In this case, we need a number of valid facts for the virtual machine to consider a fact as a real value. Then we take an average of those values and calculate the final average. Other operations are about elasticity rules. We can create, update, get, or remove a rule. About servers, we can get lists of all servers of a tenant or get all rules of a single server. There is another operation available to update the context server, the context of a server. This is an operation performed by the contest broker to build the facts about a server. And finally, subscription operations. users can create, get, or delete subscriptions between servers and rules. About actions, we support two different actions as notifications: notify scanning and notify email. The first contains a message for scale up or scale down a server in the action name parameter. Notify email sends a notify email with the address and a message with the body, which is sent to an email server to inform users, and that's all. More possible actions will be implemented in the future from notifications, like check that our virtual machine is alive and responding to pings, restart virtual machine, move virtual machine between nodes, stop virtual machine. In summary, all you can imagine. Finally, we support for operands to control parameter values, CPU, memory, hard disk, and network. These are greater, equal, less, and less equal. These operands mean that if I want that memory is higher than a number or is smaller than a value, then the action is fired. Okay, and now I would like to show you a real demo. I have in this console screen a log with the environments instantiated. This log shows all facts received from monitoring. The first operation we need is a get token to get a valid token from OpenStack Keystone. We perform a post request to this URL where is Keystone listening. To the content should be username, password, and tenant. Okay, tenant, username, and password. And we should get a response with the status equal to 200 OK and a JSON body with the valid token. I already get my token, so let's perform a first get tenant information. This tenant exists, and a policy manager checks that. Okay, we perform a get operation, and this is our response, 200 OK with information. We can see the server is running, the documentation URL, the version, and the Windows side. Okay. Let's get a list of servers. I have a server ID. I have to clean the environment because I have a rule created. Let me check. Get server info. Rule is subscribed. Okay. Server ID. Let's copy that. From a delete operation. Okay. Let's check that everything was okay. Okay. Now it's clean. We can continue without any problems because everything is okay. Okay. Now server. Now I'm going to create a new rule for this server. Let's change this value name for alert overhead. Okay. And this value for 95 to fire the action easier. When any flag arrives with the value higher than 95 or equal, it will fire the action. This request is a post request, and this is the response with the rule ID and 200. Okay. Now we can get the server and see there is only one rule in server. This is a rule. Okay. From this moment we can subscribe our server to the rule. Now I will the subscription request. Okay, notify URL. It's the address of the server you want to inform when conditions are taking place. I send the command. Okay, now server is subscribed and should start receiving facts from the virtual machine. Okay, as you can see, this is the log. Okay, now we are receiving. The conditions are in the normal range of values. The server does nothing. If any condition are taking place, the environment alert user, sending the post request to the notify URL. In this case, we see that CPU and memory are higher than 85 and tries to post the notification to host to notify, host2notify.com. In our case, host2notify does not exist, but if really exists, server will get the message. In other case, we can see the notification was sent because no sent because conditions didn't take place. Now, if we check the server information, we see that the rule and server is subscribed to the rule. Let's see. Let's run info. Okay. The description is created and the server is updating the context data. Okay, if I want to unsubscribe the server to the rule, I'm going to send a delete request to the policy manager with the subscription ID. This is the subscription ID. Right. Subscription and the subscription ID. So I send the delete command. And policy manager returns 200 OK, and if we check the details of the server, we see that everything is correct. Stop receiving facts from context broker. Let's return to the presentation. If you have any doubts, you can find information in this reference, the open specification of policy manager, clips, Redis, right, and SQL. The page contains all information. And thank you for your patience. I hope you use the component and feel free to improve and suggest anything of your consideration. If you want to join the community on Twitter, you can follow FIWARE. Thank you.